Welcome to this video tutorial, one of many in a series designed to get you up and running with Leapfrog. In this video, I will discuss the tools available for editing surfaces built in geological models. As you've seen, Leapfrog builds surfaces very quickly directly from the input data using a 3D modeling algorithm called a fast radial basis function. Seeing surfaces being built this way can sometimes lead one to feel as though they don't have very much control on how the surface looks. This video will cover the tools available to you for editing surfaces created by Leapfrog and the order in which you should use them. A first-pass surface created in a geological model using drill holes is the result of connecting contact points in a simple isotropic environment, as we see here. Given how quickly Leapfrog can generate these first-pass surfaces, this is a great place to start, but not always a good place to stop. A common first edit is to decide whether or not you want Leapfrog to snap to points. This can be applied to the overall model by simply double-clicking the upper-level geological model and applying snapping. Right now we can see the default is that the snapping is turned off, but now we can decide whether or not to apply snapping to all data we use in the geological model or just the drilling. In this example, I'm going to choose to snap to all data. Snapping can also be applied to surfaces individually by double-clicking the surface you want snapped, clicking on the Surfacing tab, and selecting the Snap to Data. As you can see right now, we are inheriting from the GM, but we could also choose from the different snapping options available for each surface. After snapping to the drill holes if required, I recommend applying a trend to the surface. By default, surfaces are built in an isotropic environment, so connectivity in any direction isn't preferred over any other direction. Applying a trend introduces anisotropy that can help to connect intervals in the desired orientation. Applying a global or structural trend is covered in different video tutorials. At any point during the construction of a surface in a geological model, additional data can be added to that surface by simply right-clicking it in the project tree and selecting Add. You can use this tool to add surface mapping to the surface, for example, by adding GIS lines. You could also add structural data or polylines or points if you'd like to modify that surface using any of those data types. The next option for editing surfaces is to actually edit them on the fly in the geological model using polylines and structural data. As you can see, this is also accessed by a right-click of the surface of interest, Edit. Here we see you can edit with a regular polyline, a curved polyline, or structural data points. I'll start by editing a surface with a curved polyline. For more detailed description on drawing in Leapfrog, please see the Drawing in Leapfrog video tutorials. As we can see, by selecting an edit with a curved polyline, Leapfrog has moved into a slice view so that we can create our polyline edit on the slicer plane. To begin the edit, I'll click on the Draw Line tool and simply draw the line I wish to use. Once the line is how I'd like to see it, I simply click Save and Leapfrog will reprocess the model to honor the new polyline. To achieve the desired results, you may need to draw polylines on a couple of different sections. Next, I'll show how to edit a surface using structural data. Editing surfaces using structural data is a similar process to editing with a polyline. This simple data set doesn't have the greatest need for a structural disk edit, but for the purposes of demonstration, I'm going to edit my D2-D3 contact. Once again, I'll start by right-clicking the surface I wish to edit, Edit with structural data. Next thing I need to do is draw a slice where I'd like to make my structural edit. If I'd like this surface to come up on this end, I can simply select the structural disk, select to draw and slice, and create my structural disk. As soon as I click Save, Leapfrog will regenerate that surface to honor that structural data point. Surfaces can also be edited by adjusting the value clipping parameters. I'm not going to cover that in this video tutorial, but there are details available for this online in the value clipping article in the Leapfrog blog.